So today we're going to talk about integrating schedule and resources across multiple projects in complex program management environments. So this presentation is a summary of my 30 years of experience as a salary and business solution provider in formal project management with manufacturing engineering companies. This material is considered quite advanced from a technique point of view, and best practices do not necessarily are found in any books or articles. So next we want to thank of our sponsors. If it weren't for our sponsors, these virtual events would not be possible. So let us answer a question on complex program management environments. So the goal of this presentation is to answer this question and provide information to allow you to think differently and allow you to gain some benefits in your future endeavors. So the question is, how is it possible to implement complex program management environment system using commercial enterprise-wide technology to improve time to market, improve on-time delivery of projects, and also in one of the two examples I'll present at the end is to eliminate $500,000 of unrecoverable annual costs. So let's now define what complex program management is. So you'll see here a list of 9 major causes of complex program management. The two most common ones that I have found in my experience is the yellow one at the top, one very large project among many projects, or multiple projects competing for the same limited resources. There's also many others, like you'll see time, distance, and culture, complex organizations, funding milestones on the same project or program after it started. So now let's define automotive and truck capital expenditure program requirements for success. So you'll see on this chart the scheduling columns. So the dynamic scheduling to forecast trouble projects is a requirement because most capital expenditure programs for new model cars or trucks always have last minute trouble without recovery time. So we call this dynamic scheduling, the ability to forecast troubled projects. Another requirement is to schedule multiple projects for a vehicle program. So many vehicle programs have scores of programs for different vehicles and hundreds, if not thousands, of projects. So the last major one is the automotive needs an exception management visibility. So there's an old axiom in manufacturing that says, if you cannot measure it or cannot see it, you cannot control it. So if you look at the resource management side, most of these plants and engineering departments work regular hours and overtime, from 40 to 66 hours overtime. So they need a way with resource management to be able to schedule overtime and reduce the schedule when they work that overtime. Another requirement is them to integrate their man hours and resources with schedule, which drives their ability to look at capacity. So they also have the ability that when they do projects, they many times are subcontract outside overallocated resources. This happens normally in automotive 30 or 40% of the time, and we'll show an example at the end. So let's provide resource managers with a project management driven dispatch report, which is a formal method, an innovation just recently created to communicate priorities. And last but not least, almost all resource management is driven in manufacturing companies by the ability to provide an accurate load capacity forecast for both active projects that are currently funded and planned projects. So the next question is, why does this industry have so many challenges that remain unsolved? So if you look at this next slide, you'll see what I call a spaghetti chart. This shows all the current programs and all the future programs. Current programs normally are in the 6-month to 12-month range that are funded, and future programs are all the new models that are funded from the board of directors and clay models on through the process. So you'll see that almost all automotive companies have a variety of different tools they use with all the data in different places. Resource spreadsheets, text documents, schedules, business systems. So all these are very difficult, if not impossible, to get integrated information and simplified information. So now let's look at all the types of tools that are being used in automotive. If you look at this slide, you'll see two different sets of diagrams. The one on the left represents the fact that probably 95 to 98% of automotive people today use a Gantt chart for projects for scheduling and a Excel sheet in the lower left side of the left-hand view. And only a very few people, I'll call this person the project B, project manager B, he's a project portfolio management subject matter expert. This person is using the project tool exactly correct. You'll see a Gantt chart with a critical path and a baseline and variances. So let's now, how can this technology provide the next frontier toward project management productivity, defined as high impact? This next slide shows the whole principle of how all this works. The lower left, the black slide, shows portfolio, which is doing the right projects up the y-axis, and project management doing projects right on the x-axis. The increase of the realized value in either of these two directions will improve the ability of the company to execute. The problem is that most companies, especially in automotive and many other manufacturing areas, do not have the ability to have good data from project management and doing things right. And since that information is required to doing the right projects, typically, but not always, we start with doing the right things right on projects. If you look at the diagram to the right, this is a typical Gartner Research Magic Quadrant study that's been done for 8 to 10 consecutive years. And you'll show that the leaders, there's 6 leaders of manufacturing software tools, of which Microsoft is one of them. It's not only one of them, it turns out it is one of the best ones. So now, for my purposes today, I have chosen to focus on doing projects right for the rest of this presentation, for the reasons I just mentioned. Now, what does project portfolio management technology for doing projects right look like? This is shown on the next slide. You'll see on the bottom half there are multiple projects with Microsoft Project, or some people call it standalone. This includes scheduling, resources, and costs if it's necessary in a standalone environment. The top half shows an enterprise version, which is the Microsoft Project Server, which is Windows Server, Project Server, an SQL database, and a Project Web application. This connects all the projects into a single database, allows them to be published to the web, and the web access through SharePoint to all data for those people who have authorized access. So the central database is the most powerful feature in project management. It gives you the ability to integrate and synchronize resources to drive the schedules, and if you see it, you can therefore control it. So now next let's look at how we're going to leverage EPM by application solution techniques to the industry's capital expenditure program and project needs. So this is represented by the scheduling toolbox in the upper right-hand corner. And this scheduling toolbox consists of several things. The key thing is a dynamic schedule project family, which the project family will yield a troubled project forecast visibility that most people never attain. So the key to this methodology for this templates can be that projects are forecast accurately, they will identify troubled projects, and early in the cycle it allows the program manager, the executive, to recover early. A troubled project in the right-hand side, you'll see the impact from an exception management point of view. I call it the critical path exception visibility tools. So you'll see 3 bars there. So let's assume you have 50% of your projects are troubled, represented by the first bar. The second bar is represented by about 40% of critical path on those troubled projects. And that 40% is based on the last 30 years of experience I've had of an average of many industries and many companies. And then the last bar is the supercritical path percentage. What is the supercritical path? The supercritical path are all those tasks on the critical path that have very long durations, could be long lead time for forgings or purchased items, or it could be many hundreds or more than that man hours that are driving it. So basically, anyone who follows this methodology has 50% of the troubled projects, and in this example, 40% times that is about 20% net result, and about 50% of that is supercritical path. So they can actually manage the entire group of programs, entire group of projects, which many times is scores of programs and hundreds of projects with only 10% of the effort. This is a major benefit. So let's call the dynamic scheduling the gold standard of doing a dynamic scheduling. So let's understand next how the dynamic scheduling gold standard works. You'll see here is sum total of my experience and my salary in consulting business of all the different types of industries that we've done. And the key takeaway here is that every different industry has by its own internal definition, whether it's ever been utilized or not, a template or a project family can be turned in a template. Why do you want to use this technique? The reason you want to use this is one of the problems that most people face in getting a good dynamic schedule is they don't want to spend the time or effort to spend, which is normally fairly substantial up front, to create a template or a project family for the different project families. The example we'll show at the end of the session today is an example where a company was doing $30 million and had hundreds of projects, and they only had 11 templates, one for every different part family. So typically, when you create project families, only about 20% of them follow the Pareto principle, which is the vital few, which is 20% of the project families, and 80% of those are the trivial many. So templates are an application of the business and project management processes. It's basically a network diagram, which is nothing more than a process diagram that allows project to calculate the schedule correctly. This allows engineering, sales, marketing, finance, manufacturing, launch management, business managers to all have their own cross-functional parts of the process. A typical template that drives and make a copy is the same as the accept project would typically take, my experience, from once it's done correctly, a half hour to 2 hours per project to create. This is a very small investment for projects in the last 10 or 20 or 30 weeks, or sometimes 1 or 2 or 3 years. So let's take a look at the new PM scheduling innovation, the Resource Manager Capacity Dispatch Reports. So here you'll see a diagram of a tool called the Dispatch Report. These are created using cross-functional work centers. Internally, there's our engineering, programming, machining, assembly, and work centers involved. Externally, you have purchased material of any substance that are buy items, and many times, as I mentioned earlier, subcontracted services. So web-based reports allow you to view, print, export to Excel these web reports once these reports are written. These reports in Project Server are written with SQL services, reporting services, and they create this report that contains all the data. You'll see the data across the top shows baseline information, planned start and finish dates, actual start dates, actual starts where that applies, remaining work, and also the critical path. So what's interesting about this tool is this tool provides all the resource managers with the things that would normally come from the program manager. It provides a schedule of all the activities updated on a very current basis, and it shows what priority. In this particular case, this tool has been prioritized to show critical path Y equals yes or N equals no, and worst case finish variance. So this allows more time for the project manager to identify trouble and recover. Doesn't require him to give this information to the resource managers because they are authorized to go get the information on the web themselves. So everyone has access to all the work center and the buy dispatch reports. So how can a scheduling toolbox be the foundation for this resource management toolbox we just discussed? So this shows the resource tool project management toolbox. So this is fundamentally work calendars with overtime tools. So many different areas, both engineering and shop operations in automotive, work anywhere from 40 regular hours to up to 66 hours per week in schedules. So you have to set up multiple calendars that can be used that represents the hours that are planned to work in these areas to get the amount of time available for the schedule to be driven across these resources. So multiple projects can place resource demands on the same limited resources. these resources are then fully integrated with the schedule. So in other words, the resource man-hours drive the schedule. The more the resource man-hours, the longer the schedule. The more the calendar time, the lower the schedule. So the primary output report is a monthly resource capacity forecast, which you see in the lower right-hand corner. Literally almost all the companies in automotive today, especially tier 1s and tier 2s, forecast or attempt to forecast their resource capacity. So what does this chart represent? The bars are resource demand. The resource demands are those demands required to meet the schedule. The line chart are the capacities of the resources using alternative overtime work schedules. So you may have a 40-hour line and a 50-hour line and a 66-hour line with different amount of capacities based on the amount of overtime planned to work. Now let's look at the new resource overallocation innovation where critical path again plays a key role. So you see on this diagram on the lower left-hand side in yellow, 4 bars. It's very typical in manufacturing experience in automotive that the overallocated resources in future months is normally stacked up where they're over capacity for 2 or 3 consecutive months at a time, and they're backed up back to back. In this particular case, I've represented this by the 2 bars in the middle on the left-hand side. So the other problem is that before and after 2 or 3 months of overallocated resources, you will normally have a period where the resources required for that particular resources are underallocated, represented by the left-hand bar and the right-hand bar. So this technique is basically to take the critical path tasks on these programs in the second month on the left-hand side and accelerate that so that it moves forward into the earlier month. Now, this has to be fairly selective because normally most projects have about 40% of their projects tasks on the critical path. So you have about 40% of 100% of the tasks in the second month to pull this off and get this done. So this involves adding manpower, possibly subcontracting, working more overtime, and so forth. Now, there's also, you'll see a capacity under allocated resource on the right-hand side of this bar graph. So this is much more simple because we take a slack path. So the slack path on a typical project is 60%. So that means there's a lot more slack path tasks to go do this than there are with the critical path. So when you observe what happens, and this is easily to be able to manipulate it with a dynamic schedule and project, you'll see on the right-hand side that by moving one or more critical paths to the left 1 month and 1 or more slack paths to the right 1 month, that we've almost totally resource leveled the entire requirement for that resource. This is very possible, and this new technique was introduced to a customer who's actually doing this as of 2 months ago. So now, what is the impact that does the scheduling toolbox and the resource toolbox have on doing projects right, our original subject? If you look at this next slide, you'll see 2 projects that we talked about earlier, but now we see that the less experienced project manager A is now doing everything correct because he's using a template, and the subject matter expert is still doing everything correct. So what happens here is you'll see on the far right-hand side of this diagram is at the top next to the Gantt charts is that project center view. This project center view is available in Project Server, and it will roll up all the projects. It will roll up projects by program and provide you any data. If you put the data in, you can get it out. The second one in the lower right-hand corner is a resource center view, and this tool in Project Server rolls up all the resources. So it shows the resources and the capacity, and it shows them for all the different projects. So if we go back to the axiom, if you can measure it and you can see it, you can control it. So you can see by using these kinds of tools and the manners that we've just shared with you that you can now see what's going on all your projects and see if there's slippages or running ahead of schedule. You can see if there's overtime. So now, what overall impact does this have on project manager effectiveness? A term coined by one of the companies I work with that called this the PME, or Project Management Effectiveness. So if you look at this diagram, you'll see 6 bars on the left for standalone process integration, and you'll see the width of every yellow bar represents the amount of effort by the program manager to schedule a project, then to work through the resource requirements, which is in a different database, do the capacity planning either in the resource requirements database or somewhere else, track his budgets and costs in another place, perhaps do earn value at the bottom, or perhaps do master schedule, which isn't as common except for aerospace. And you'll see that the multiple databases calls the total width of that effort on the left-hand side using standalone process integration methods is very, very long. Now, if you look at the right-hand side, you'll see all those same 6 database information where they're all integrated. So the fact that all those bars are closely tied to each other and near each other, and you'll see a single blue bar going through that. If I add up all the width of the single blue bar, you'll see the results at the bottom in total is a effort from using one single database that's significantly smaller than the yellow one on the left. So this is kind of proof when you look at this diagram, what we find by experience when we work with companies that they can get 2 to 4 times more good quality productivity and effort out of their program managers by using the tools we described earlier. So now what evidence is there that project management technology methods and applications can actually produce meaningful results? If you look at this slide, this slide summarizes 3 different companies that have gained high performance game-changing results. So we see an OEM captive die construction plant on the left-hand side. On the right-hand side, we see a first-tier heavy-duty axle supplier that had to spend $18 million of capital expenditures from product design initiation all the way to launch to the customer. And then a third one in the lower right. You'll also see a quote made by Dr. Jay Barron from Center for Automotive Research when he saw the results and how the operation of the captive OEM worked. So now let's look at doing things right game changer comparisons. This slide shows game changers all together, all 3 of the ones in the previous slide. So if we revisit the complex projects, if you remember at the beginning we defined complex projects, there were 2 main types that I have tended to see a lot of in my experience. One of them is one large project. So this project at the top was one large project. It was first of a global rollout of new products. It had a product design, the test track, the manufacturing engineering, $18 million of capital expenditure launch at 5 plants, and it used all the toolbox items except the capacity forecast. The capacity forecast was not available to this company because they required a project scheduling system for one large project that's described here be put together. And so we didn't have capacity of all the smaller projects because we didn't want to take as much time as it would take to do all the projects. So at the end of every month, there was a forecast of all the different departments and how much effort it was going to take. And every department manager, from product engineering to manufacturing engineering to the plant, had to state how much of this project effort in man hours could not be done by their resources and their area of responsibility. And then it was up to upper management to prioritize that in a meaningful way to keep the project on track. So this project was done in about 5 months, and it was done in a single version standalone of Microsoft Project. And you can see the results. It was 100% on time at the end of the 31 months. The 31 months was 27% better than any project in the history of the company. So let's look at the second example. The second example is the other example I pointed out on the slide about defining complex programs. And this is multiple projects. This particular company had the epitome of multiple projects all competing for the same limited resources. They had engineered to order captive tool and die plant. They had about 300,000 man hours of effort. Everything was run on a project basis. Projects averaged between $1 and $2 million each. There were 5 programs going on between active and planned at one time, and there were more than 40 to 60 different projects at one time. You'll notice that this has a significantly shorter lead time of like 36 weeks when we started this effort, and it was collapsed down to 20 weeks, which is a 17% improvement. So PPM technology doing project right, the evidence is clear. Now, what can we conclude about the application of PPM technology to achieve high performance in this particular industry? If you look at the final slide for today, we have conclusions. So I have four major conclusions. The first one is that you take a serious look at adopting and leveraging EPM, which can significantly reduce project complex program environments and provide high impact results. Number two, or item B, is to develop project family templates first with dynamic schedules. Set baselines, create a critical path to forecast, and identify troubled projects. Then manage the trouble. And item C is have executive management buy-in and require the rigorous follow-up of the standard set of reports. Those standard set of reports are shown, which we shown earlier in each of the slides, as what I call the standard web-based reports. And these can include tracking Gants, load capacity reports, and dispatch reports on the web, and also budget man-hours performance, which we did not discuss today. So the payback against time and effort to do this with licensing costs can be expected to be less than 12 months in general, no matter how big or small. And I do welcome your questions, which is the final slide. So thank you for attending this virtual conference today.